Today's objective is I can find the measurement of a missing angle by writing an equation and applying a strategy. So we're going to be looking at all different types of angles where we are given certain angle measurements, and then we also need to solve for missing angles. We're going to be doing this by writing an equation with the help of our part-whole chart and applying a strategy to solve. Before we get started with our first problem for today, I want to go over a few benchmark angles. So earlier in the year, we learned about benchmark angles, and these are angles that we memorized. We saw them, we knew exactly how much they measured, how many degrees in each angle. So we started with a circle. When we measured the degrees in this circle, when we measured the angle in a circle, we found that it equaled 360 degrees. That's a full circle. So if I was standing still and I jumped and turned in a full circle, that would be 360 degrees, a 360 degree rotation. Now, when we folded that circle in half, or we cut that circle in half, we got a straight angle. And this was another benchmark angle, right? When we measure this straight line, we get 180 degrees. Now, when we folded that in half, we got our next benchmark angle, 90 degrees. And that makes sense because 90 plus 90 is 180. And if I added 180 plus 180, we'd get 360. Now back to our 90 degree angle. When we folded our 90 degree angle, or we cut our 90 degree angle in half, we got our 45 degree angle. And this was our next benchmark angle. And then our last benchmark, we added our 45 degree angle to our 90 degree angle to get our 135 degree angle. So today, as we're solving our next problem, I want us to keep these really important benchmark angles in the back of our minds. They're really going to help us solve this next problem. Mackenzie jumps in the air and rotates 120 degrees. She jumps for a second time and rotates 90 degrees. How much does she need to rotate to go a full 360 degrees back to her beginning position? So this problem looks a little bit different than the problems we were solving yesterday. First thing I notice is we're not given a picture. So I go to step 1 on our anchor chart, draw and label angles. This step is going to be really important in figuring out how to solve this problem. So going back to our problem, Mackenzie jumps in the air and rotates 120 degrees. So she's jumping and she's rotating or spinning in the air. So first thing I want to do is go ahead and draw that 120 degrees. So your drawing does not have to be perfect, right? We're not using a protractor or anything, but we're still going to do our very best to draw 120 degrees. So we start with one line. 120 degrees I know is an obtuse angle, right? It's greater than 90. So I'm going to draw my second line about right here. And we're going to label that 120 degrees. Then she jumps for a second time and rotates 90 degrees. So 90 degrees is easy, right? That's a benchmark angle. We could use a perfect square corner to help us draw this. But the way I'm going to draw this is I'm going to draw it right next to my 120 degrees, right? It's a continued rotation. So I'm going to just draw my 90-degree angle right alongside my 120-degree angle, kind of stacking it. And I'm going to label my angle 90 degrees. So she starts here, and she jumps, she rotates all the way to here, and then she rotates another 90-degree angles and stops there. Next, my final question asks me, how much does she need to rotate to go a full 360 degrees back to her beginning position? So I want to solve for how much she needs to rotate to go a full 360 degrees or back to her beginning position. So we know she started her jump right here. So we want to figure out how much more she needs to jump to get back to that starting position. And we know that a full circle is equal to 360 degrees. So we are solving for this missing angle here. We're also going to label, we know that this whole rotation of my circle is 360 degrees. From our starting point all the way around, back to the beginning. So let's go back to our steps to solve. We're on step 2. Draw a part-part whole chart. Oh, well, our part-part whole chart usually has 2 parts and a whole. But we can draw these charts to include however many parts we need. Because when I'm looking at this picture, I've got 3 different parts here, right? My 120-degree rotation, my 90 degrees, and then my missing piece. We also have our whole. So the way that we're going to draw this is we're going to label our whole, right? That's the same. And instead of splitting this bottom piece into our 2 pieces, we're going to split it into our 3 pieces. So now I've got a part whole chart. So you can adapt this chart to fit any of these problems. So first up, let's label what we know. Well, we know our full circle or our whole rotation is equal to 360 degrees. So let's plug that in. We know that our first part or our first rotation is 120 degrees. We know that our second part or our second rotation is 90 degrees. And we also know that we've got a missing part, a part that we're solving for. I'm going to label that with a question mark. Now we have our picture completely labeled and drawn. We have our part whole chart drawn and filled in with everything we know. Now we're going to move on to step 3. Identify our operation. Are we adding or are we subtracting? Well, we learned yesterday that if I'm given 2 parts and I'm solving for my whole, we can add those 2 parts to solve. Now, if we are given our whole and given 1 part, we can subtract to find the missing part. So when I look at our chart, I see we've got 2 parts, a missing part, and I'm given my total. That tells me that we're going to subtract to find our missing part. So we start with our whole. My whole is 360 degrees. I'm going to subtract both of my parts to find my missing part. So my first part is 120 degrees. So let's subtract that first. 360 minus 120. 0 minus 0 is 0. 6 minus 2 is 4. And 3 minus 1 is 2. So now we're at 240 degrees. But we're not done yet. We still have to subtract our 90 degrees. So I take 240. I'm subtracting 90. 0 minus 0 is 0. 4 minus 9, can't do that, so we go and borrow. 14 minus 9 is 5. And I bring down my 1. So we've got 150 degrees. So let's fill that back into our chart. Now, last thing we can do is we can add all 3 parts up to see if they equal our whole. That's a really good way to check our work. So we're going to check our work right over here. We've got 120 degrees, 150 degrees, and 90 degrees. Let's add those up. We've got 0, 16, and 3. 360 degrees. That matches. So we can go back over to our picture, fill that in. And that answers our question, how much does she need to rotate to go a full 360 degrees back to her beginning position? 150 degrees. All right, so we did a lot of work in this problem. We used everything that we knew about benchmark angles. We solved our first additive angles problem where we weren't given a picture, we had to draw it ourselves. And we saw our first additive angles problem where we had 3 parts instead of 2. So go ahead to the next video and we're going to solve a problem together.